This is Todd Frazee, and this is the video tutorial for the S60 143 cam for the drive rod. Alright, so this particular part, we know we have another part that looks almost identical to it. That's the 145, it's a little bit longer. And then if we go back and look at the 117, it's also very similar. The only difference is instead of a double-sided tab, the 143 and 145 have half-round flats. So all the drill sizes, all the lathe cuts, everything is basically the same except for this end here, which will change. And then we'll be able to program the 145 by copying the toolpath for the 143 straight up. Okay, so let's go look at our models. Okay, so on the left we have the 147, and on the right we have the 143. Before we go any farther, we do want to make the sketch for the revolve for the 143 visible before we forget. Okay, and then we're going to zoom all the way to the right and pick on the milling symbol. Okay, it's probably a good idea to save at that point. And let's go over to the 117. Now we're going to copy, right click on the lathe ops and select copy. We're going to go over to the other file. We're going to say paste. And then we will go back to the 117 and we're going to copy the mill setup. And we will paste over here as well. Alright, let's go back to the 117. Let's save it just to make sure we don't lose anything. And we can close that file, maximize the 143. And the first thing we're going to do is we're going to come through, change the names to the operations to the proper part. Okay, and then we're going to set up our jobs. It should be pretty quick because they're more or less very similar. Okay, same diameter rod, everything. So we're going to go edit. It looks like it's actually assumed most of what we need. So we're going to go to the 143. And we're going to scroll down. And this would be the 143 one. And 43. And it looks like I got lucky, and in my case, it went ahead and associated it with the correct model with the right orientation and the correct z-axis. Now, if yours doesn't, you need to select the end here to define z. Your x needs to be in the same axis as your same plane as your sketch, and it looks like it pretty much did what I needed here. So I guess it's similar enough, and my selections are okay for that one. Alright, so let's hit OK. Then we're going to move on to the setup for the milling. Let's go edit. Yes, I know I have to regenerate geometry. And put it on the end. And our stock is the model itself. And it looks like everything's orientated the way I would want it. Our datum's on the right with all our features dimensioned off of that. So let's change our designations. And we should be able to accept that. Alright, so we're going to start with our lathe ops. We're going to come up to the top and we're going to do a turning face. So let's see how that's interpreting it. Okay, right now it would cut the model correctly, so that's good. And it's going past center. So it looks like we'll be able to just accept that toolpath. We're going to edit our single groove, and we want to select under geometry. We're going to select our arc at the bottom of the groove, and we do want it offsetting to the back and to the tip. Go to the next step, and it auto selects the face of the cylinder that's next to it, which is fine. So just to review, if I were to delete that, we want to go up to the cylinder face, and the next two tabs we can just leave it default. Okay, so we've got our grooving tool coming in just to make this corner sharp. Alright, so now we're going to go to our turning profile. We're going to go edit, and I would suspect we need some work there, but it looks like it selected the same chain. So perhaps because I modeled these all back to back and their IDs are identical, sketch numbers, and I was just modifying sketches and copying them to make the next part, it's associating them. If yours doesn't, you'll need to select the individual segments and under geometry here, and make sure that the all of the line segments are selected. Okay, so we have our confinement. We're going 180 thousandths past, and that's for our cutter, our parting tool to come and cut off. Okay, so all these other diameters should be the same, and let's hit accept. Alright, so we get some rough cuts and then a final cut out here. I'm not crazy about how this enters, but that's okay. Now we just have to part off the material. So we're going to go turning part, edit, and it looks like it selected the same line I had selected. And we'll hit accept. Alright, so that was pretty quick. We've now regenerated all the turning toolpath for the 143. Now let's go on to milling. Alright, so we had several routines to cut the tab. Now in this case, we don't need to cut the underside, so there's no real reason to use a saw. We were just using that as convenience because we could get both sides at the same time. So we're going to delete the routines. Oops, not the name. Well, okay, so all the tab operations get deleted. We need to replace it with a end mill cut. Okay, so the overall width of that feature, width on that feature on the 143 is 236 thousandths. So a 1/4 inch end mill could do it, or a 3/8, and we have a 3/8 end mill in our library, and it can come through and do this pretty much in one horizontal pass. We would want to take a couple vertical passes. We could use the 1/8 inch cutter, but then you're going to have to take several passes at it. So I think I like to use the 3/8, and we're going to go to 2D milling, and you want to make sure that the correct operation's bold, which means it's the currently active operation. You have to right click on it to tell it to be active. And we're going to do a 2D contour. And we're not going to use this end mill, so we're going to go to the library, and we're going to go to mill tools, and we're going to select the 3/8 flat. Okay, and you notice it's wider than the actual flat. We're going to do more than one pass just so we have a finished pass. 40 inches a minute's fine, as long as our fixture is very rigid. I'm making the sketches invisible for the moment. I don't need them for the milling. Two. I want the edge. There we go. So those three edges. But we don't want to propagate around Z. We don't want to do a full loop. We just want a straight line. Okay, we're going to heights. We're going to leave everything at default here. And we're just cutting to the contour. So that's pretty straightforward. The next is we want wear compensation. We are going to climb cut. We're not going to do multiple finish passes, but we do want a finish pass. So we're going to slow down the finish pass to 20 inches a minute. The rough pass can go faster. Okay. What's interesting is it doesn't actually open up with the correct boxes till you hit roughing passes. And then your finish pass step over occurs. So we're going to do a finish pass of 0.02 on sides. So it's 20 thousandths. And then it's going to be at 20 inches a minute. We're going to keep scrolling down. Our rough passes, it's somewhat academic. We really only need one. You really don't want it any higher than 80% of the diameter. So let's actually do that. 0.375 is 3/8 times 0.8 would give us 300 thousandths even. Okay, we're going to do one step over. And we are going to do multiple depths. And really all I want to do is have one finish pass at the bottom. And we're going to put that at 0.02 also. And our maximum step down, we're going to set that at half the diameter, so that's 3/16. Okay. We're right on center line, so we don't really need tangential extensions. On our rough cuts, we want to finish it only at final depth on the side, and we're going to use even step downs. We're going to go to the next tab. We are going to have the tool lift up. We're going to come in at 0 degrees. We don't need a lead-in radius if we're doing that. And then our lead-in distance, we want to bump that up to a little more than half the diameter. So if half the diameter is 3/16, let's bump that up to 0.2. We're going to accept that. All right, so we get one rough cut and a couple finish cuts at the bottom. All right, so that contour, we want that to actually occur at the beginning of the program. We're going to move that up. So we're going to label that as a 2D contour of a flat. Okay, now the spot drill. Remember, we want to do all our drilling before we cut the slot over here. So we should be able to go edit and leave the first tab at default geometry. Because I copied my model, it auto selected. If yours doesn't, you need to select the two holes that are highlighted. And the next tab, we should be able to leave all this at default. And the last tab we can leave at default. There we go. So we've now spot drilled our link. Now we're going to do the drill bit that goes through and pre-drills before the reamer. Edit. It looks like it selected the holes automatically because it was a copied model. Got our three faces selected. Got to make sure auto merge is selected. Go to our heights. We can pretty much leave everything at default. Our last tab, everything at default. Done. Now let's go to our reamer. So this is the small reamer. So for the small hole, which is these two here, looks like they're already selected. Leave everything at default. Leave all this at default. Make sure auto merge on whole segments is selected. It should be. And then we're going to regenerate that. Now we're down to the last hole here, which hopefully will just translate over. So it automatically selected the hole in my case. If it didn't, you need to select that hole. And then we go to the next tab. All our heights stay the same. All the rest of that stays the same. Bam. Okay, now we're going to go to the slot. Not sure how this is going to behave. Okay, so we select our slot, and it looks like it's cutting on the wrong side of the line and may not have associated properly. So let's take a look at it. We're going to go to geometry, and it is this edge. And our heights, we're going to start here, end here. We're going to leave all this at default. We're going to leave all this at default. Let's hit accept. And my toolpath actually regenerated on the correct side of the slot, so we're good there. And so pretty much there you go. We've now programmed the 143. Now I'll let you simulate so you can see what it looks like. Don't need to waste your time in a video doing that with the amount of experience you have. Okay. Make sure you're saving often. Again, you gotta submit one setup sheet and one code file for each of these operations. Alright, that's it for the 143. I'll catch you on the next one, which is the 145.